Hello friends, welcome to UGPG Mathematics. In this video, I am going to solve problems from IIT-JAM 2020 Mathematics. So the first problem is we have to find the coefficient of x raised to 4 in this 3 upon 1 minus x into 1 plus 2x. So let us just write down the partial fractions for this, which is you take 3 outside as it is, and let us just adjust the terms. So it is 1 minus x, 1 upon 1 minus x plus 1 plus 2x. So when you just cross multiply these terms, so we will get this 1 plus 2x plus 1 minus x. So we need here 2x, so that this 2x will get cancelled with this 2. So just multiply by 2. So now see here, it is 1 plus 2x plus 2 minus 2x. So 2x will get cancelled and it is just 3. So in the numerator we have 3, so you just divide it by 3. So when you just simplify it, you will get this as 3 upon 1 minus x into 1 plus 2x. So this 3 will get cancelled with this. So we have 1 upon 1 minus x plus 2 upon 1 plus 2x. Now we know that this 1 upon 1 minus x is same as 1 plus x square plus x cube plus x raised to 4 plus x raised to 5 and so on, plus this 2 into, can write this as 1 upon 1 minus x plus 2 into 1 upon 1 plus 2x. And similarly you apply this series, since 1 upon 1 plus alpha is same as 1 minus alpha plus alpha square minus alpha cube plus alpha raised to 4 and so on. So you apply this formula to this series. So this is 1 minus 2x plus 2x square plus minus 2x cube plus 2x raised to 4 and so on. So just simplify it. So this is equal to 1 plus x square plus x cube plus x raised to 4 and so on, plus this is 2 minus 4x plus 16x square minus, this is 8x square minus 16x cube plus 32x raised to 4 and so on. Now we have to find out the coefficient of x raised to 4. So these are the higher powers of x. Again, these are the higher powers of x. So we have just the coefficient of x raised to 4 is here, it is 1, and the coefficient of x raised to 4 here it is 32. So just take the sum, it is 33. So the coefficient of x raised to 4 in 3 upon 1 minus x into 1 plus 2x is 33. Let us solve another problem. We have x square plus y square into x is equal to c is a solution of this differential equation, and we have to find out the value of m at 1, 1. So we know that this solution must satisfy the given differential equation. So let us convert this solution in the differential form. So differentiating on both sides of this equation, we get the derivative of x square is 2x, the derivative of y square x is, now this is the multiplication of the function y square and x. So by product rule, first function into derivative of second, so derivative of x with respect to x is 1 plus second function is x and derivative of y square with respect to x is 2y into dy by dx, which is equal to c is the constant of integration, so its derivative is 0. Now simplify it, so we will get 2x plus y square into 1 is just y square plus this is 2xy into dy by dx equal to 0. You take this dx here, so it is 2x plus y square into dx plus 2xy dy is equal to 0. Now compare this equation with mxy dx plus 2xy dy is equal to 0. We get mxy is equal to 2x plus y square. So m of 1 comma 1 is, you put x equal to 1, y equal to 1. So it is 2 plus 1, which is 3. So answer is 3. Now let us solve another question. So we have a non-cyclic group G with order of G is 57 and H is a subgroup of G such that order of H is equal to 19, and we have given a element G from G and which is not in H, and we have to find the order of G. So let us first write down the choices for order of G. Now see that this G is in the group such that G is not in H. So G belongs to G means this order of G must divide the order of the group, which is equal to 57. So what are the divisors of 57? These are just, so order of G can be, must belong to, this is 1, then 3, 19 and 57. Correct. So order of G must be one of these. So, and it is unique. Now G does not belongs to H, which is not in H. So this gives us, now H is a subgroup, so it contains identity. So G is not equal to identity. Correct. So order of G cannot be 1 because order of identity element, since order of identity element is 1 and it is the only element, so order of G cannot be 1 because G is not equal to identity element. Now similarly, you cannot have this order of G is equal to 57 because if the order of G is 57, then 57 is nothing but the order of the group G. So and G is non-cyclic, so there will not exist any element of order 57. So this is also gone. Now there are two options, so it can be 3 or 19. But see here, this G is not in H and order of H is 19. So if order of small g is equal to 19, then this gives us G belongs to H. But which is not true because we have given that this G is not in H. So this gives us order of G cannot be 19. So this is also not true. So we have just order of G is equal to 3. So 3 is the order of the given element G. Now the next question is, we have given Tn is equal to an plus 1 plus an plus 2, and it is just a notation, summation an is equal to s. Then sum of the sequence Tn is equal to what? So Tn is just equal to an plus 1 plus an plus 2. So to find out the sum, that is sum of Tn is equal to, you add the T1 plus T2 plus T3 terms of this, so and so on. So this is just equal to, so T1 is, you put n equal to 1, so T1 is A1 plus A2 plus A3. Then for simplicity I am writing it like this. So T2 will be A2 plus A3 plus A4. Then T3 is A3 plus A4 plus A5. Then T4 is A4 plus A5 plus A6 and so on. Correct. Now you just add this. So just see that this is A1, A2 plus A2, and now from this A3 is repeated thrice, A4 is repeated thrice, similarly A5 will repeat thrice and so on. So we have this A1 plus A2 plus a2 plus 3 times a3 plus 3 times a4 plus 3 times a5 and so on. So this is just equal to, now we have to find the answer in terms of series of an is equal to s, that is we have to find it in terms of s. So you can write this a1 as 3 times a1 plus this is 2 times a2, you add 1 a2 here, so it is 3 a2 plus 3 a3 plus so on. Now I have added 2 a1 here, so subtract 2 a1, and here I have added a2, so subtract a2. So this is just equal to 3 into a1 plus a2 plus a3 and so on, minus 2a1 plus minus a2. This is just equal to, now see, summation an is s, so this quantity is just s minus 2a1 minus a2. This is the answer. Now this is a easy question. We have to find out which of the following is false. We have given 4 options. So limit as x tends to infinity of x upon e raised to x. So as x tends to infinity, this limit have infinity upon infinity form. So by L'Hopital's rule, we have this limit as, just take the derivative, so it is 1 upon e raised to x, and as x tends to infinity, this is 1 upon infinity which tends to, so it tends to 1 upon infinity which is 0. So this is true. Now the second is sin x upon 1 plus x as x tends to 0. So when you put x is equal to 0, it is sin 0 upon 1 plus 0. So sin 0 is 0 upon 1 which is just equal to 0. So this is also true. Then C option is limit as x tends to infinity of 1 upon x into e raised to 1 by x. Now orally, as x tends to infinity, so as x tends to infinity, this 1 by x tends to infinity, 1 upon infinity which is 0, and therefore e raised to 1 by x tends to e raised to 0 which is 1, and hence x into e raised to 1 by x tends to 1 upon infinity as x tends to infinity. So 1 upon infinity tends to 0. So this is also true. And lastly, this must be false because at least one option must be correct. So this is the answer, but let us see. So as x tends to 0 plus, now cos 0 is, this is cos 0 upon 1 plus 0. So cos 0 is 1 upon 1 plus 0 is 1 which is 1, but it is not equal to 0. So this is the wrong option. Hence this is the answer. Now next question is, we have given a set D is equal to xy belongs to R2 such that mod of x plus mod of y is less equal to, and we have given some options about this D. So it is open or closed, or there are some options. Now let us draw the set. So we have this mod x plus mod y is less equal to. So now we are in R2, so there are 4 quadrants. So in the first quadrant, we have this x and y both positive, and by the definition of modulus, when x and y are positive, we have mod x is just equal to x, similarly mod y is equal to y, which is less equal to. So this gives us y is less equal to minus x. When you write this in the equation form, it is just equal to y equal to 2 minus x, and hence it is just a straight line. It is 2 comma 0, this is 0 comma 2. So this is the straight line, and now see here, this 0 comma 0 satisfy this equation because 0 plus 0 is less equal to, so, and 0 lies here. So from this we get this region. So now let us go for the second part. So when in the if in the second quadrant, sorry, this is not here because we are just in first quadrant. So this is the region. Now in the second quadrant we have this mod x is just equal to x, minus x, because here x is negative and y is positive. So x is negative, that means mod of x is equal to minus x, and y is positive, so modulus of y is y is less equal to. So when you write it in the equation form, you will get y is equal to 2 plus x, and hence the line will be like this from second, and this 0 comma 0 satisfies this because minus 0 plus 0 is always less equal to. So and 0 lies here and we are in the second quadrant, so this part is the region we want. Now here in the third case we take the third quadrant. So from third quadrant we have x is less than 0 and y is also less than 0. So this equation becomes mod x is just equal to minus x because x is negative. Similarly, mod y is minus y because y is also negative, which is less equal to. And this gives us x plus y is equal to minus 2 in the equation form. So which is just equal to minus x minus 2. And hence this line is which passes through these 2 points. This is minus 2 comma 0 and this is minus 2, 0 comma minus 2. And now this 0 satisfies this equation because minus 0 is always less equal to. So this part is the required region. Now in the fourth quadrant we have this x is positive and y is negative. So this equation becomes x is positive, so mod of x is just equal to x, and y is negative, so it is modulus of y is minus y, and which is less equal to. So in the equation form we have this is y is equal to x minus 2. So draw the line y is equal to x minus 2, and now see here when you put 0 comma 0, it is 0 minus 0 is 0, which is always less equal to. So just take the region which is to the in the side of 0. So this is the required region. Now from this diagram, the shaded region is the set D. So now this region also includes these boundaries. So this is a closed region in R2 and hence this set D is a closed set. Now the next question is about the sum of the series. So write down the general term for this series. So it is just summation an is equal to summation 1 upon n into n square minus 1. N is running from starting from 2 to infinity. So to find out the sum, we take the partial sum, which is Sn is equal to a1 plus a2 plus a3 plus so on up to an, and then we find out the limit of Sn to get the sum of the series an. So let us write down what are these terms. So here an is equal to 1 upon n into n square minus 1. So just simplify it, we will get 1 upon n into n square minus 1 is n minus 1 into n plus 1. Now take the partial fractions of this. So it is just equal to 1 upon n into, just adjust these terms. So n minus 1 n plus 1. So divided by 2. Now this is equal to 1 by 2 into 1 upon n into n minus 1 minus 1 upon n into n plus 1. So this is our an. So just write down Sn. Therefore this Sn is equal to a1. So what is a1? It is 1 by 2 into 1 upon it is starting from 2, so it is a2 plus a3 plus so on up to an. So this is up to an plus 1 because we are starting from a2. So this is when you put n equal to 2, it is 2 into 1 minus 1 upon 2 into 3 plus 1 by 2 into, when you put n equal to 3, we'll get, it is just 1 upon 3 into 2 minus 1 upon 3 into 4 plus 1 by 2 into 1 upon 4 into 3 minus 1 upon 4 into 5 plus 1 by 2 into 1 upon 5 into 4 minus 1 upon 5 into 6 and so on, plus the last term is 1 by 2 into 1 upon n plus 1 into n plus 1 minus 1 is just n, and minus 1 upon n plus 1, just replace this n by n plus 1, so it is n plus 2. Now see here, when you just open the brackets, we will get this 1 by 2 is just common, and it is 1 by 2 minus 1 by 2 into 3 plus 1 by 3 into 2 minus 1 by 3 into 4 plus 1 by 4 into 3 and so on, minus 1 upon n plus 1 into n plus 2, because this term will get cancelled with this, so alternating terms are getting cancelled. So not alternating, consecutive terms. So this is just equal to 1 by 2 into 1 by 2 minus the last term is 1 upon n plus 1 into n plus 2. So this is our Sn. So just take the limit as n tends to infinity of Sn. So we will get the sum of the series S is equal to limit of Sn as n tends to infinity is equal to 1 by 2 as it is, and as n tends to infinity this tends to 0, so it is 1 by 2 minus 0, so 1 by 2 into 1 by 2 is 1 by 4. This is the answer. Thank you.